In this video we're going to show how to find the equation of a line which three planes meet along, and then we're going to show how to use the equation of a line to find a point that satisfies all three planes. So the first thing I'm going to do is to eliminate one of the variables from these three equations, and it looks like I've got the same number of y's in two of the equations, so I'm going to make it so I've got 5 y's in equation 2 as well. So I'm going to do equation 2 multiplied by 5, so I get 5x plus 5y plus 5z equals 3,500. I'm going to call that equation 4. So I'm now going to do equation 4 minus equation 1, and that's going to give me 3x plus z equals 500. I'm now going to do equation 3 minus equation 4, and I'm going to get 3x plus z equals 500. So I've got the same equation in each case. If this was going to be equation 5 and 6, and I do 5 minus 6, I get 0 equals 0, which is consistent, and that informs us that we have a line that satisfies the equations. So the next thing that I need to do is to use what I've got here to help me to start to find the equation of a line. So I'm going to start by making this z equals 500 minus 3x. So that gives me a connection between z and x. Now what I want to do is find a connection between z and y, and the reason I'm using z is because I've got z the subject in this case here. So what I'm going to do in this case, if I go back to the original ones here, if I multiply equation 2 by 3, I get 3x plus 3y plus 3z equals 2,100. Now I can substitute in this equation here, which is 3x equals 500 minus z. Try and fit that in there. So that's going to give me 500 minus z plus 3y plus 3z equals 2,100. So that's going to give me 3y plus 2z equals 1,600, which is going to be z equals 1,600 minus 3y all over 2. So now I've got a connection between x, y and z. So I can add it a different form on the next one, so we'll just get rid of this. Did something differently just straight off there. So we've got, for the x term, we've got 500 minus 3x. 500 minus 3x equals, and then for the y term I've got 1,600 minus 3y over 2, and the z term is just a z. So there's the equation of my line. Now what I want to do is find a point that satisfies them all. So I could try z equals 100, and if z does equal 100, I'd end up with, if I use the x side, 500 minus 3x equals 100. So x equals 400 divided by 3. Now that would be fine if I was happy with non-integer values. But what if I wanted integer values? Well, in that case, this wouldn't do. So I'm just going to have to try a different number. So what I'll try now is I'm just going to try z equals 200. So if z equals 200, we have 500 minus 3x equals 200, which gives me 3x is 300, which implies x equals 100. Well, so far so good for x and z. What about for the y value? Well, that will give me 1,600 minus 3y over 2 equals 200. That was our z value. So that's 1600 minus 3y equals 400. So that implies that y equals 1600 minus 400, which is 1200, divided by 3, 400. So there we go. Just by a bit of trial and error, I've got a value for x of 100, a value for y of 400, and a value for z of 200.